Howdy, Mr. Lee here. All right, on to numbers 19 and 20. Directions say find the inverse function and state its domain. So here's your original function. This is number 19. The procedure to find your inverse is to switch your x and y positions and then solve for y. Okay, so originally you have y equals 5x plus 10. F of x is replaceable with your y value, right? So we're going to swap the x and y positions. That's what your inverses do. So this becomes x equals 5y plus 10. And then we solve for y, and that's our inverse function. Right? So subtract 10 on both sides, divide by 5. This is your inverse function. You can also use this notation, the f to the negative 1 of x. It's not actually a negative 1 power, that's just kind of the notation for it. So inverse function is x minus 10 over 5. And then they ask for the domain. So with your inverses, both x and y's, they swap, right? So that means the domain of your inverse function should also match the original range of your original function. Okay, so this is a linear function, which means your domain and range all real numbers. So that means your domain for the inverse is also all real numbers. You can get a visual, right, using a graph. So if this is your original f of x, right, again, it's just a linear function. Domain is all real numbers. Range is all real numbers. Because the range is all real numbers, the domain of your inverse, which is this guy, is also all real numbers. And you could also put the graph side by side for an extra visual. Let me graph the inverse, x minus 10 over 5. Right? These graphs are inverses of each other. We can also see the domain of your inverse is all real numbers. Okay, so that's number 19. Let's go to number 20. Number 20 is, we have the 8th root of x plus 2. So again, same thing as y equals. Right, f of x interchangeable with y. Let's now swap your x and y positions and then solve for y. To undo an 8th root, you just raise everything to the power of 8. That'll undo the 8th root. So you have y plus 2 now on the right side. And then we're just going to subtract 2 on both sides to get y by itself. And again, if we wanted, we could use this notation, right? Inverse of x is equal to x to the power of 8 minus 2. So these are the same thing, y equals or the inverse. Okay, and on to the domain, same thing. Because we're switching x and y, the range of your original function should be the domain of the inverse. Okay, so we do have a restriction here. You have a root, right? We can't take a even root. We cannot take the even root of a negative number. So basically, the domain of, well, your domain gets restricted, but then whatever is evaluated with your 8th root has to be a 0 or a positive number, right? So we can see that again with a visual. If I graph this, right? Ranges should be a 0 or positive number. You cannot take the even root of a negative number, which is why that range is all positive. Right? And then further, if we graph the inverse, these aren't quite inverses yet because we have to match these functions 1 to 1. So your domain is going to be, your domain of the inverse has to be the range of your original. So if your range of the original, as you can see from the red graph, right, it's just x is greater than or equal to 0. That's what your range also has to be. Sorry, that's what your domain also has to be for your inverse. Okay. So if I restrict that domain, now you're going to see the proper inverse graphs. Right? Originally, this was the x to the power of 8 minus 2. We only want to consider x values that are 0 or positive. So there you go. So the domain here should be x is greater than or equal to 0.